Okay, my dear students, in the previous video you have already seen the different types of unit cells, the simple cubic unit cell or primitive unit cell, then the body-centered cubic unit cell and the face-centered cubic unit cell. You might have already studied in the previous video. So based on that knowledge, your prior knowledge, today let us discuss about the relationship between the nearest neighbor distance d, the radius of an atom r, and the edge length a of a unit cell. So I have already drawn the figure on the board for a simple cubic or primitive unit cell. The figure looks like this. We all know that in a simple cubic unit cell there are atoms placed at the 8 corners of the cube. So we have here 8 points or 8 lattice points or lattice points. I have placed atoms at the 8 corners of the cube. Now, what is the nearest neighbor? Okay, the nearest neighbor. Suppose you are sitting in the class. Okay, there are 3 friends who are sitting in this class. This is one friend, this is another friend, and this is another friend. So for friend number 1, friend number 2, friend number 3. Friend number 1, for friend number 1, who is his or her nearest neighbor? For friend number 1, the nearest neighbor is friend number 2. So the nearest neighbor will be the nearest neighbor distance will be the distance from friend number 1 to friend number 2. In the same way, in a cube, when the atoms are arranged, the nearest neighbor distance will be the smallest distance between the 2 nearest or closest neighbor. One approximation you have to take in a cubic unit cell is that here you see that the atoms are placed at the corners and they may look far apart from each other, but actually these 2 atoms, they touch each other. So these atoms are considered to be solid spheres that touch each other. That is the assumption we have to take. So let us get started with the derivation, the relationship between small r, small d and the edge length a of the cubic unit cell. So first we are discussing about simple cubic or primitive unit cell. So let us consider 2 atoms. Let us consider this red sphere as atom A and the red sphere as atom B. Now the closest distance between for A atom with any other immediate neighbor is either this B atom or maybe this C atom. Okay, so I am just assuming A and B is the shortest distance. A and B lies close to each other. So let us get started. We can write in a simple cubic unit cell, atoms at the corners lies close to each other. I hope you can read what I am writing. I write slow, I write small. Okay, so you are able to see, I believe, in the video. In a simple cubic unit cell, the atoms at the corners lies close to each other, or we can say they touch each other. Okay, therefore the nearest neighbor distance between the atoms d, we can just assume it as d, and d will be nothing but it is AB, and AB is nothing but it's called A. Okay, AB is the edge length, okay, or the side of the cube, length, breadth or height. Okay, there are 3 parameters: edge length, breadth and height. So let's consider D as A. Now I'll just draw and make things more simplified here. Let us assume these 2 atoms are touching each other. Okay, this A and B are touching each other. How will it look like? A and B, they touch each other. Okay, these are the center of the atoms. This is atom A, this is atom B, they touch each other. Now this is A, it is the edge length. Now what will be the radius of the atom? The radius of atom will be small r. And what is small r? Small r is nothing but edge length divided by 2. Edge length divided by 2. This length is actually A by 2. Okay, this length is actually A by 2. So edge length divided by 2 gives me the radius of this atom in the unit cell. So therefore radius of the atom radius of the atom r will be d by 2. Okay, nearest neighbor distance divided by 2, and that is nothing but a by 2. So thus we have calculated the radius of the unit cell, which is nothing but r is equal to a by 2. So students, this formula is very important for solving the numericals in this chapter. So there are two more derivations, we'll come to that slowly. So please copy it down for a better understanding.